Okay, so we are at Daocheng Airport in the mountains of China. We are going to try and I've tried to do this about 3 times now on the stream just to get the saw right. We've got the temperature is at 60 degrees. The pressure is at let's just get a time read so we can actually see what's going on as well. Okay, the pressure is at 948 millibars. The temperature is at 60 degrees Celsius, so that is way very, very hot compared to the ISA standard settings of 15 degrees and 948. So I'm just checking that I've got the time right. Hopefully it won't default to going dark. It seems to do it sometimes. So this should make it very difficult for the aircraft to fly. Density or relative density is all dependent on a few things. It's dependent on the temperature of the air. The altitude of the runway is not going to help because the runway we're taking off at 14,000 feet above sea level. And the service ceiling of the Cessna 152 is only 14,700 feet. So what we're going to find is that the aircraft's going to be struggling with performance. It's not designed to fly this high anyway, and the safety margins built into the design of the aircraft, so it should be able to climb slightly on a normal day, climb slightly above its service ceiling. We'll find today that it can't. Yeah. So what we're going to do is we're going to put the aircraft throttle up to maximum. Take the safety. We're taking the parking brake off. Yeah. And if we look at this airspeed, because we've got a very low density day, okay, where airspeed's just crawling up there, 10 knots, 11 knots, yeah, 20 knots, it's really struggling to get moving, okay, and then we will be able to take off. We will get enough, we'll probably get 40 knots out of the aircraft, yeah, but as you can see, that needle there, I'll just point out the thing I'm talking about there. So there's the airspeedometer there that I'm talking about there. Okay, and then if you look, we'll also look at the altitude, which is 14,500, just shy of that. And then this vertical speed indicator, when it's on the 0, that means a straight and level flight. Okay, so when we pull back on the stick, it should climb. That's our climb meter, or vertical speed indicator, to give it its proper name. Okay, now if you look at the VSI, when we get, so we've got 60 knots there. Okay, quite a long takeoff. It took a long time to get to 60 knots. As soon as you pull back the stick, our speed's dropping off. And to get that VSI to go to 5, which would be 500 feet per minute. Okay, so if we hold it at 500 feet per minute on the VSI, as you can see, the speed's dropping off. We've only got about 50 knots now. Holding it at 500 feet per minute climb rate. Okay, well, altitude's coming to 14,700, and as you can see now, we can't hold that climb. We've reached the ceiling of the aircraft. Right, the weather's not helping us, the temperature's not helping us, sorry, the pressure's not helping us, the temperature isn't helping us. The aircraft's now actually pointing nose up and it's actually falling out of the sky. So you might hear the stall warning any minute. We've lost our airspeed. Let's put it back into level flight. I'll just dive a little bit and then we'll get it back to level flight and we'll see what the aircraft will fly at. So if we level it out there perfectly level on the VSI, I'm not climbing a bit there. Okay. So there's level on the VSI and we're getting about 60 knots. If we leave that for a good couple of minutes or a minute or so, that'll climb up to about 66, 70 knots flat out. Okay. The aircraft cannot push it. It's got less drag. The only thing that's helping it at this altitude with this temperature and low pressure will be there'll be less aerodynamic drag. However, what we got 65 knots. That's our maximum speed. And as we saw before, 14,800 feet is the maximum altitude we're going to get. So the aircraft will gently climb up to that altitude, but it's not going to fly any higher. Right. Now, let's try the same thing, and we'll go to a different airport. Right, now this is mainly for students at Newcastle Airport, Newcastle Aviation Academy to look at. So what we're going to do now, we'll go to there, we'll go flight conditions again. And this today we're going to set it to a normal day, an ISA standard day, 15 degrees. Okay, we're going to keep the pressure 1013.2 millibars, which is your standard if you're flying on flight levels. You would set it to that anyway, but we're going to set it to that. So it's ISA standard. I just need to change the time because we're at 3 o'clock in the morning, so it'll be a bit dark. Okay, so there you go, same time of day. Hopefully that'll go to daytime again. Yep, we've got other players on there, but it doesn't matter, we'll just upset them. Right, and then we'll fly at Newcastle and we'll see the change. Hopefully we'll see a change in performance of the aircraft. We're 250 feet above sea level instead of 14,000 feet on this flight. And then we'll see we should have more thrust, we should have a more sprightly takeoff, more lift, a lot shorter takeoff run, and then we should get maybe it's about 100 knots, a bit more. We'll see what kind of top level speed we can get. So this is just to kind of illustrate the fact that when the weather changes, it changes the flight parameters of the aircraft. If we put the weight of that aircraft at the Cessna, we could do another one if I had time. And if we put the weight of the aircraft up, then we might find it wouldn't be able to take off at all from Daocheng. Okay, so this is a near sea level airport. As you can see, our speed's climbing a lot faster. We're up to 40 knots. If you look at that dial in the bottom left of the instrument cluster, or the instrument panel, you can see straight away we're up to 70 knots. Take off, and then there's that 500 feet on the VSI. We can get up to 1,000 feet per minute easily. So a climb rate of 1,000 feet per minute, twice what we could achieve at Daocheng. Okay, and away we go. Now in the denser air at low altitudes, if we then stick the nose down a little bit, and we'll stick it down on a level flight, I'll try and keep it level there. The nose up there. Okay, and straight away you can see without any effort whatsoever, and I'll leave it there to prove that wasn't attained in a dive. There we've got 100 knots. Yeah, no problem at all. Yeah. Okay, right. And then what we've got in here, right, I'm going to have to end this video now because I've just got something else. 2 seconds, let's pause it now. Sorry, there was just something going on at home, I had to get a little bit distracted. So there we've got 100 knots, yeah, we've got a slight climb there, and as you can see we can usually get a climb rate of 1,000 feet per minute. Yeah, 1,500 feet per minute, no problem at all. We'll lose a bit of speed in the climb, but you can see the differences in performance. It also means when you turn the aircraft and you're going, you know, you're not losing any speed in the turn, and the aircraft will actually turn tighter in the thick area as well without stalling. So they've got quite a high rate turn going on. And we don't have to worry about stalling. Okay, and there's Newcastle again. Thanks for watching this. I'll see you in the next video quite soon.